Hey, 12th graders. So we are continuing on with our financial algebra, but of course, as always, we're going to make it just a little bit more difficult. So we talked about last class about having financial algebra with just compounding. We talked about the comparison between simple interest and compounding interest. That compounding interest was essentially just our geometric sequences, in other words, just exponential modeling. But we also learned about using our financial solver. With this making it more complicated, we're going to learn today about annuities and amortization. Both of these guys are more complicated where you have to use the financial solver in your calculator. GDC, graphing display calculator, math notation for just saying use your calculator. You cannot use the formula. Maybe write that down. You cannot use the formula for compounding interest because it gets more complicated, because with annuities and with amortization, we add in this extra level of payments. Annuities are when money is growing. Amortization is when we're trying to pay off money that we've borrowed, right? So annuity is that we're trying to save money. Amortization is paying off money that we borrowed. So that's the difference, and we'll kind of go through each of those separately. So an annuity is typically for saving money. You'll see in these questions below that it says that it has an annuity of this. How you know that it's an annuity is that you are saving money and making payments, saving money and making payments in some way. Example 4 and example 5 have making payments in two different ways, but they are both dealing with payments and they are both dealing with saving money. So those are how you know that it's an annuity. Things that change with annuity with our financial solver. PMT, our payment, right? It stands for periodic money transfer, which is a payment, right? Periodic money transfer. These are like, it could be a monthly installment, right? Or like a yearly installment. So they are money installments, maybe. So it's the amount that you put in, the amount of the payment. That is probably a better way of phrasing it. Something else that changes is your PPY. This is payments per year. And so if you had monthly installments that you were paying, well, then that would be 12 payments per year. PPY would be equal to 12. If you had quarterly, it would be four times a year you make this payment. So that's something that changes. The last thing that changes is your N. So these are the three things that change in your financial solver that we talked about here in your finance app: the N, the PMT, and the PPY. The N also changes because N is number of payments. And we said earlier that it's typically years. And that is true when we only have like compounding interest being re-put into the formula or being re-put into the bank account. Whereas here, if we have a number of payments, it could be if we're making like monthly payments for 5 years, that's 12 payments for 5 years, so 12 times 5. So it changes into away from years or using years to help us figure out the number of payments. I'm not doing a great job of explaining this. Let me show you an example. Monthly installments for 6 years would be 6 times 12, monthly for 6 years. The number of payments is 72, right? So it's not just the number of years anymore when we're talking about annuities and amortizations. It's how many times are you making that payment per year, and then for how many years, and then you multiply that together, because it's technically not number of years for N, it's number of payments that we're making. So those are the three things that change. And that we'll need to keep in mind if it's switching from just a regular compounding to when we have any sort of idea of a payment in our problem. So Charlotte decides to save for a yacht. She would like to have a million Turkish lira at the end of 10 years. She saves every year in an annuity, so that's how we know it's an annuity, that pays 4% interest to calculate how much she has to save each year. Okay. We know it's an annuity because it said an annuity. We also know it's an annuity because we're talking about interest, we're talking about saving money. So we know that we're building up money and we're talking about an amount that she has to pay or pay to the bank each year, right? Each year, how much does she have to like put into the bank? So it's satisfying both of these things, saving money and making payments. So we know that it's that. So when you know, then, okay, I know which drawer of my memory of math things that I need to pull out in my filing cabinet in my brain. Okay, I know that I'm in financial algebra. I know that I'm not in compounding interest. I know that I'm either in annuities or amortization. I'm going to pull out that drawer and figure out what tools are in that drawer. Well, I know that my tool that I have to use for that drawer is the financial solver. And with the financial solver, I have a list of variables. Okay, those variables are and now it's just a list of things that you have to figure out in terms of the context of the problem, what goes in. Deal with the easy stuff first, right? Like 4% interest, awesome. That's 4, done with that. The present value, or maybe we can say, okay, we have to know how much she has to save each year. That's a payment, so that's an unknown. What do I do with 1 million? Well, that's what we want at the end. At the end, we want to have 1 million that goes into my pocket, which means that's going to be my final value. My final value is a million. There we go. And it's positive because it's going out of the bank and back into my pocket at the end of this process. Okay, now 10 years. 10 years would typically go in for our N, and we just have to pause and ask ourselves, how many payments are we making per year? Which, hey, that's our PPY. Okay, well, it says that she is making a payment each year. So that's 1 time a year. So PPY is 1, which means N is 10 times 1, which is 10. So that's still just 10. Awesome. Compoundings per year. Compounding is when all the money gets calculated and put back into the account. Well, the money is calculated and puts back into the account each time she makes a payment, right? So that's compoundings per year, also just 1. Present value. We have to think, well, what are we starting off with? We're not putting an initial value into the bank, right? We're not like immediately depositing something and hoping we get to a million. We're just starting off right now with nothing. So it's actually 0. You're going to notice with annuities and amortization, this relationship between present value and final value. One of them almost always, or typically, will have 0. Either you're trying to pay off a loan, which comes to 0, or you're starting at 0 and want to get to a lot more money, right? So we are now starting to introduce this idea of either a present value or a final value being 0. Okay, now I have all the things that go into my graphing calculator. So now I can put them in for this guy. So, okay, oops. N is 10. I is 4. This is your calculator menu 8-1, right? So if you're trying to figure out where that happened, pause the video now and get to the same place as me, and then start typing this in. 0. Payments are what we're trying to find, so I just automatically delete it and then move on. Final value is positive 1 million. Payments per year, 1. And if I scroll down, it does this. So I have to scroll to the right twice before I can scroll down, which is annoying. It's also 1. Instead of scrolling up, I'm just going to move my cursor to go up, right? This is the PPY and the CPY. If you scroll up or down, it changes the number. It gets really frustrating. I get really annoyed by it. So what I do is I just use my cursor to get out. Okay. You put all of this in and then you press enter and it gives you the value. The value is negative 83,290. So PMT equals negative 83,290. And if I'm rounding to the nearest whole number, I'll do 91. Actually, let's do 2 decimal places. I don't know if Turkish lira does 2 decimal places for its currency, or if it stops at, I don't know. If one of you does know, come into class and say, hey, this is how Turkish lira is measured. I'm thinking about it from the perspective of euro or American dollars, that we go to 2 decimal places, but not all finances, not all currencies go to 2 decimal places, but I'll put it like that for now. Now, what does this mean to have a negative number? That means out of my pocket every year, one time a year, sorry, I got paint under my nails. Out of my pocket comes 83,290. So that means every year Charlotte has to save 83,290.94 Turkish lira. That's why it's negative, is because it goes out of her pocket. And that's her yearly payment that she has to make if she wants to save 1,000,000 Turkish lira by the end of 10 years, which is a lot of money. Okay, let's get it to be more complicated. I want you to try starting out this problem on your own. Yeah, because it's not the end of the world if you get it wrong. So Julia has been left an annuity of 5,000 in a will. This annuity is for 5 years at 8% per annum to be paid out monthly. Find the monthly payments. Slightly different than the problem above, right? In the problem above, Charlotte was just building money to get to a certain value. Here, we still have money. It is an annuity because it says it's an annuity. We have money that's being saved and used at the same time, but still being saved. We're not like trying to pay off a loan or anything like that. So it's an annuity because we have payments, and it's the idea of saving money. So we know that this is going to be this list. And then we just take it one step at a time. What are all of these things? And I want you to practice this process on your own. And then I'll go through and tell you what they end up being and the thought process behind it. Okay. So I'm going to just go through and deal with the money that I have, or like the values that I have up here. And then I'll try and see what else I need to fill in. Julie has been left an annuity of 5,000 in a will, which means that if this is going at 8% per annum, that this is going into the bank. So that 5,000 is going into the bank, and it's what I'm starting with. So, okay, initially 5,000 has been given to me. I'm trying to think about, if I was Julia, what would this mean? 5,000 has been given to me, but it's been put into a bank to build interest. So it's technically coming like out of my pocket and into the bank, and it's what I'm starting with. So that's my present value, and it's negative 5,000. That's the thought process. I had to kind of think about, okay, well, how would this work in context? So what does that mean? It means I start with that money, present value, and it's technically coming out of my pocket and going into the bank. So it's a negative. Okay, the annuity is for 5 years. Okay, so that looks like it goes for 5, but I need to make sure I double check with annuities, with payments. And hey, it says monthly payments. So that'll be 12 monthly payments. So that means the number of payments is going to be 60. Okay, I kind of did a jump here. I didn't finish the sentence before I figured that out, because I was able to kind of spot monthly payments. Okay, that's fine. Annuity is for 5 years at 8% per annum. Okay, so that's then 8, to be paid out monthly. So monthly, that is my payments per year. I have 12 payments per year. And if that payment is then being recalculated and put back in every month, that means that's how many times it compounds